Hey guys, this is the lab that is the velocity of waves on a string lab. So I'm going to do the best I can to show you this based on what the classroom setup looks like. It's kind of hard to video, but I'll do the best I can. The data I will give you, and that's nice and easy. So right now, this is the source of this. I have a frequency generator here. I don't know if you can see the number on it, but it says 3.7. That's 3.7 hertz, or 3.7 vibrations per second. What this device here is essentially a speaker. Now, this speaker is just being pushed up and down 3.7 times per second. And then we have this little holder that holds the string onto it. So the string is being moved up and down 3.7 times per second. And I've set this up, and what we have here is one entire wave on the string. So take a look at the string, and hopefully you can see that there is one wave on it. Let me show you the points of that. Okay, so right here we have an antinode. Okay. Right here is the central node, and over here we have another antinode. So the string from here to there is exactly 7.54 meters long. You might want to write that down. 7.54 meters long. Now, if you want to find out how long a single wave is on that string, the best way to do that, to account for sometimes there's going to be an odd number of antinodes, the best way to do that is to take that 7.54 and divide it into the number of antinodes that you have. That's the regions that are going up and down like that. Right now, we have two of them. So you divide it into the number of antinodes you have, 7.54 meters divided by, in this case, 2, and then you need two of those regions to make a single wave. So in this case, 7.54 meters divided by 2, multiplied by 2, I think you can see your way through. This 7.54 meters is a single wave. The frequency generating that is 3.7 hertz. Okay. Your job now is to calculate the velocity of that. So download that page, do the calculations. V equals F lambda. 3.7, 1 over seconds, times 7.54 meters. Well, a meter times a 1 over second gives you meters per second. So it immediately gives you the velocity of the wave on the string. Good. You got it calculated? Now, let's mess with it. All right, so well, if we take a look at the string now, let me count the antinodes. I have one antinode here. By the way, this is not automatic. I have to get an exact frequency to get this to work. Otherwise, it's just a mess. This thing isn't making standing waves at all. But I have 1, 2, 3, 4. 4 antinodes. How many complete waves do I have here? Well, it takes 2 antinodes to make a single wave. So I have 2 complete waves here. What is the length of a single wave? 2 waves together, that distance does not change, 7.54 meters. Now the frequency is 7.4 hertz. All right, let's see if we can't mess with it even more. All right, now it's got to be getting hard to see here. I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 complete antinodes. So how many complete waves do I have on this? How many complete waves if I have 8 antinodes? Hope you came up with I have 4 waves. So this 7.54 meters is broken now into 4 waves. The frequency is 14.8 hertz. So you have 3 different velocity calculations I hope you have done with this. What did you find out about the velocity in each case? Now, I gave you simple cases. The velocity does not change. No matter what I do to the frequency or the amplitude, the velocity does not change. How could I get the velocity to change? Well, this way. Let me turn the device way down. Okay. Now, I go down here. This is elastic string. So if I change the tension on the string substantially, have I changed the medium? If I change the tension on the string, does that automatically change the medium? Well, yes, it does. So should we get a different velocity? I don't want to give the lab away, but let's see, okay? So I'll dial the frequency down, and the first thing I have to do is find where I get a wave. Now look at this. This is a mess, right? This is not so easy to get at all. I have to dial this in. Until it makes there. I think I have it. The only way to do it is to go off of it, think you have it, and you want the antinodes as big as possible. All right, so now we have a single standing wave on it again. And again, notice how much trouble it is to get a standing wave. Everything has to line up perfectly. This frequency is 6.0 hertz. The length has not changed from before. It's still 7.54 meters. So now do a velocity calculation. Again, 6.0 hertz and 7.54 meters. Good. By the way, this is on the back of the page where we've changed the medium. Simply changed the medium by tightening it. We tightened it quite a bit. So let's find the next standing wave. Once I have the initial frequency, I can see how to do this pretty quickly. The key is, though, adjusting it till it's perfect. This is as perfect a wave as I could get. The data, well, the length hasn't changed, but how many waves are on it now? Well, I count 1, 2 antinodes, 3 antinodes, 4 antinodes are on this, and the frequency is 12 hertz. So do the velocity calculation here. Okay. 12 hertz. There's 2 complete waves on this. The total length of the string is 7.54 meters. Okay, you got that? All right, I'm moving. All right? All right. Nice. This is 18 hertz. And now I have 1, 2, 3, 4, 5, 6 complete antinodes. Again, it's 7.54 meters, but now there's 6 complete antinodes there, right? So you want to divide the 7.54 meters by 6, But you need 2 antidotes to make a standing wave, so then multiply by 2. Okay? My frequency is 18 hertz. What's the velocity? So, what do you learn from this lab? What do you learn from this lab? What causes the velocity to change? Frequency? Amplitude? Wavelength? Does that change the velocity? I think you could see, based on what you got on the first set of data for velocity and the second set of data after I had made it a lot tighter, that no, the velocity stays the same regardless of the frequency. What changes the velocity? What changes the velocity is changing the medium. So the only way to change the medium, in this case, would be by putting a new rope in, tightening it, which is what we did, or something else where you're actually changing the medium. If I got this wet, it would change the medium. But if I change the medium, that's what changes the velocity. So certainly tensioning this, tightening it, changes the medium. So you can ask a question, what is a guitar player doing when they change, when they say they're tuning it and they tighten the string? What are they actually changing? They are changing the velocity on the string. Therefore, they're changing the frequency that would set up on that string a standing wave. And that's the key to everything. So, hope this makes sense. Nice, simple lab. What does it prove? That the velocity is dependent completely on the medium, period. Pretty good. Hey, thanks for watching. Do all the questions on the lab. Make sure everything is written nice and neat. How do you do nice and neat lab work? Well, I'm thinking Givens formula S&S. You bet. And that makes it very clear to everyone who reads your labs. Don't forget that. You're going to go to college, you know. Bye-bye.